Okay, so basic probability, what I want to walk you through in this illustration is to demonstrate some basic probability relationships, such as the probability of an event, the concept of the union law, which is the addition rule, also the concept of mutually exclusive events, and the concept of a complement. So I'm not going to show you the whole thing, but just parts of it just to kind of give you an idea. So I'm going to start with this particular example where they talk about they've got 5 equally likely experimental outcomes labeled as E1 through E5. And because it's equally likely, remember the rule to assign a probability to an outcome that's said to be equally likely is simply 1 divided by n. So in this case, since we have n is equal to 5 outcomes, the probability for each one of these outcomes would therefore be 1 over 5, or I like to use decimals, I would just say 0.20. So off to the side here, I could list these. We could say basically that E1, E2, E3, E4, and E5 would each have a probability associated with that particular outcome of 0.20. So I'm going to go ahead and write that out right here. And then just to show you the basic rules of probability, if you were to sum up your probabilities, you would get a total of 1.00 or 100%. Now, the problem says in part A, find the probability of event A, B, and C. And the basic definition of an event would be all the sample points in each event. And if you look at event A, you have the outcomes E1 and E2. So to find that probability, you simply look to see, well, what's the probability of each of these outcomes, which is 0.2 and 0.2. So you'd say the probability of event A is therefore 0.40. Now, if you went and looked at the probability of event B, it's the same thing. We have 2 outcomes, E3 and E4. And if I go to my reference, E3 and E4 is 0.2 and 0.2. So if you add those together, again, you would get 0.40. That would be the probability of event B. Now, then I go to event C, and notice you have outcomes 2, 3, and 5. And if you reference those, 2, 3, and 5 each have 0.20 as the probability of the outcome. And if you just add those together, 0.2 plus 0.2 plus 0.2 obviously would give you 0.60. And that's how you'd find the probability of an event. Now, the next idea is when they say find the probability, this is part B, find the probability of A, and see this elongated U union B. That's basically your addition law. And I'm going to write this out over here. Your addition law is A union B is equal to the probability of A plus the probability of B minus what we call the intersection. Now, just to clarify, your textbook refers to that idea as A and B, okay? And that's fine, it's the same thing, but I like to use this symbol A arch B, and I'm going to call that your intersection. So, which basically means, does event A and event B, do they share any sample points in common? And we'll see here in a minute. So, to find this addition law, you'd simply take the probability of A, which is 0.40, plus the probability of B, which is 0.40, and subtract out any intersection or any sample point that A and B share in common. And so if I look at A and B, notice A is E1, E2, B is E3 and E4. They don't share anything in common, so that intersection is actually defined as 0. So therefore, I can then find the union by simply taking 0.4 plus 0.4 minus 0, and you'd get 0.80. Now, the next question then says, are A and B mutually exclusive? And the answer to that would be yes, because the probability of the intersection is equal to 0. There is no A and B. So that is basically your definition of 2 events that are said to be mutually exclusive. Okay, so I walked you through the idea of how do you get the probability of the concept of called an event. The next idea is how to find what they call the union of 2 events. And then the other idea I want to show you real quick is how to get this thing called a complement. So a complement, so for example, if the probability of event A is equal to 0.40, a complement would represent any sample point not in that particular event. So if I look at event A, I see E1 and E2. The complement would basically be all of the other events in your experiment that are not in event A. And so the complement, if I list the outcomes, it would be E3, E4, and E5. okay? Because these three experimental outcomes are not located in event A. And each of these have a 0.20 probability. So if I wanted to find the probability of the complement, it'd basically be 0.60. And I like to use this symbol. This is a very common symbol, A and then a C. I know your textbook likes to use a little squiggly line, but I like to use probability of A complement, you would say is 0.60 by simply doing it like this. Now, the quickest way to actually get the answer, though, since we already know that the event A is 0.40, you could just take 1 minus 0.40 and get 0.60. That's probably the fastest way to do it. And for future reference, if you ever have to do complements, and again, this is just a general method type of problem, the way you're going to typically calculate the probability of a complement is by taking 1 minus that particular probability. Okay, so again, I hope this one helps you.